Hello students, this is Miss Mason here. We are here for lesson number 2. This is number 2 in the geology unit. Remember, geology, study of the earth, the solid parts of the earth, including rocks, and also the processes that change those rocks. So geologists would study geology. Today, we're just going to go through plate tectonics. So this is a theory about how the plates in the lithosphere of the Earth moved over millions of years and formed the position of our continents today. So plate tectonics is a theory of geology. It's a theory, but it is supported by a lot of scientific evidence. So scientific theories are supported by evidence. They cannot be proven. However, they can be disproven, and they are really based on evidence, scientific evidence. So they can change if we discover new evidence to support a new theory. But they can be supported through evidence. So scientific theory is a scientific principle that is supported by evidence. Plate tectonics is a theory involving geology, Earth. And it just is it's the movement or a large-scale movement of the continents on planet Earth. So question number 1. We're already getting started. And remember, pause the video at any time. So question number 1 is to name the 2 types of plates, or the 2 types, sometimes they call it the crust. So 2 main types, the crust of the Earth. Hint, one is underwater, one is on land. Okay, so I think I said a little earlier it was just the plates, but actually scientifically it's the 2 main types of crust on Earth. The crust, remember, is the exterior of the Earth, and that crust is underneath oceans. And remember, when it's underneath oceans, it's about 5 miles thick, the crust. When it's underneath continents, land, it's about 25 miles thick. So the crust of the Earth ranges from a depth between 5 to 25 miles. So the question number 1, stop and think. Just pause the video. Number 1, name the 2 types of crust on the Earth. Welcome back. So here we are, we have the planet Earth, and the theory of plate tectonics, remember, is a theory of geology based on evidence. If you ever go hiking, like around Los Altos, there is a San Andreas trail where you basically are walking along that fault line. So a fault line is an intersection of 2 plates, and the San Andreas Fault is about 810 miles long. It's an intersection of the Pacific Plate, which is a very, very large plate, the biggest on Earth, covers most of the Pacific Ocean, and North American Plate, which covers North America. They come together. Where they meet, they're sliding. So it's transform boundary. We're going to talk about boundaries between plates a little later. But at the boundaries between 2 plates, it slides like this. Do dance like this. This is a transform boundary. So 2 plates. We have, let's say this is North American plate, this is the Pacific Plate. They came together here. The North American one is actually sliding south, and the Pacific one is actually sliding north. And LA is on the Pacific one, and San Francisco is on the North American one. So in about 16 million years, scientists estimate that LA will actually be north of San Francisco, because those plates are still moving very slow. Things like 10 centimeters per year, if that. This is, scientists debate on actual measurements of how much they're moving, but they move, all right? They move about the rate that your fingernails grow. That's how fast they go. Okay, so anyway, that's an example. Two plates, Pacific plate, North American plate, where they come together, you get a lot of action. Earthquakes, volcanoes, not necessarily volcanoes in our case with the San Andreas Fault, but you get a lot of seismic activity because those two plates are sliding. Okay, so question number 2, stop and think. Number 2, what can you please describe, just describe the theory of plate tectonics. Theory of plate tectonics, you're going to describe it in complete sentences. If you send it to me in Google Classroom, just one word answers or whatever, I send it back, and you have to rewrite it. So complete sentence starts with a capital, a letter. The first letter of that first word in a sentence is capitalized and ends with a punctuation mark, a period. As a verb, which is an action word, as a noun, as a subject. All right, so please, complete sentence. So number 2, stop, think, give me a description of plate tectonics. Welcome back. So plate tectonics, that theory led to continental drift theory, and they're very, very similar. Continental drift just basically says what it says. It is what it says, basically. It means the continents are drifting. So they're slowly moving on the Earth because they're attached to plates. They're attached to the crust and the upper mantle or the outer mantle. That's the lithosphere. So plates move. There's an estimate between 1 to 18 centimeters per year. So we'll say about 10 centimeters per year they're actually moving. Right now, you look around, you look where you go for a hike, you go for a walk, you look down, it's like the Earth isn't going anywhere. All right, but it is. It's moving below your feet. Not on the crust itself, but below that mantle. Well, the crust is moving, yes. It's caused by that moving mantle. Or convection currents. Get it going. And number 3, stop and think. Stop, think. Number 3. I want you to tell me what continental drift theory is. What is continental drift? All right, number 3, stop, think. Welcome back. I want you, this is a review, number 4. Number 4. I want you to tell me what causes these plates to move. There's the main one I talked about in the last video, but I did mention it earlier. So, number 4, what causes the plates to move? Stop and think. Welcome back. Getting back to the crust of the Earth. The crust of the Earth is actually moving, even though you don't think it is. It is. It actually is. It's actually moving at the rate at which your fingernails grow. So your fingernails grow about 10 centimeters per year. Although I don't know, mine don't grow. Mine don't seem to grow. I don't know, like maybe, but generally fingernails grow at about 10 centimeters a year. And that is the rate that the crust actually moves. So believe it or not, the Earth below your feet is moving. Might not seem like it, but it is.
So here are the 7 tectonic plates that cover the Earth. And if we look at, I'm just going to look at this Pacific plate, right here, it covers the Pacific Ocean, and the North American plate is over here that includes North America. And you can see where they interact. Right here, this is the San Andreas Fault. So this goes through, it's about 800 miles. It's a transform boundary. So these two plates are actually just sliding next to each other. And the North American plate is actually sliding south, and the Pacific plate is actually sliding north at a rate of 10 centimeters per year, or the same rate that your fingernails grow. And so scientists are estimating that in about 16 million years, since LA is in the Pacific plate and San Francisco is in the North American plate, in about 16 million years, LA will actually be north of San Francisco. So these are this is just a picture of the plates. The Eurasian and Indian plate over here this is forming, these two boundaries are coming together. They're colliding. So that's called a convergent boundary. And this is forming the Himalayas. So the Himalayan mountains are right here. So Mount Everest, which is the tallest mountain on Earth, was formed by converging plates between the Eurasian plate and the Indian plate. So I'm just going to look through this. And this simulation allows you to view the plate boundaries. And you'll notice that when I click the volcanoes and the earthquakes, there's a pattern to their position on Earth. Notice they seem to be at the boundaries of these plates. So where these plates interact is where you have a lot of seismic activity, such as earthquakes and volcanoes. And here is a picture of the San Andreas Fault. It's about a little over 800 miles long. It goes along the coast of California. And if you hike in Los Altos area, there's actually a fault trail or a San Andreas trail where you're walking along that fault line. But these plates are sliding. So this is a transform boundary. And this is why we have a lot of earthquake activity along the San Andreas fault line.
What evidence do we have, like at the boundaries? So the boundaries where two plates come together. All right, so some things you will see at these boundaries are earthquakes, volcanoes, and landforms. All right, so landforms such as mountains, continental mountains, oceanic trenches, like a valley kind of underwater, mid-ocean ridges, which are similar to mountains underwater. So these landforms happen when the plates come together. All right, so when two plates come together, in other words, they're just interacting with each other. All right, okay. Welcome back. Next thing I want to talk about is when these continents, now if you think of all the continents on Earth, they're not all connected, but at one time they actually were. So at one time there was a supercontinent, and before that it was a supercontinent, they broke up, and then another supercontinent. So the first one we're not going to talk about, but we're going to talk about the most recent one, and that is Pangea. So pan means entire, whole, gea, think of geology. So Pangea, all the continents were together as one. So it's a supercontinent. And they've been moving for millions of years. So the original was about 250 million years ago. And this idea of over time the plates started to move, separating these continents. That theory was proposed by a scientist by the name of Alfred Wegener. And he came up with that whole idea of the plate tectonics, the plates moving. And originally they started to get all the continents started in this big supercontinent called Pangea. So, question number 5. Stop, think. Stop and think. I want you to give me 3 things that can happen, or 3 sources of evidence that plates are moving, that you will find at the boundaries. So when 2 plates interact with each other, whether it's sliding like San Andreas Fault, sliding like that, get a video. I mean, we gotta get a dance. Like this is the slide. This is called the transform dance. So
that's the transform slide.
Weirdness is awesome. Please embrace your inner weirdo. Too many people want to just conform, want to be like everybody else. Why can't I be normal? Why can't I be like that person, like him, her, or whatever? Be you yourself. Be you. The world needs individuality. The world needs some people that are different. Next thing I want to talk about is evidence, some more evidence for plate tectonics. One thing we can look, and evidence of that the continents have moved, right? Continental drift, evidence of Pangea. If we look at the continents, one thing we can look at is a conformation or the shape of the continents. If you look at them, and I'll show you pictures here, Africa, South America, kind of like are puzzle pieces. They look like they'd fit together if you pushed them together. So just puzzle piece shapes of the continents is an indication that they were all connected at one time. Okay, so that's the first main source of evidence. Some other evidence we can look at is through biogeography. So what you're wondering, what is biogeography? We're making up all these words. Bio means life. Bio, life. Geography. Right? Locations of continents and positions of them on the planet Earth. All right. So when we look at biogeography, we're looking at different species and their locations on Earth. And it can even include fossils. Now, fossils are remains of ancient life, things that used to live. Ancient. So usually they're extinct. And they're only known to be at one time alive through their fossilized remains. So I know you had to read about Mesosaurus. Meso means middle, saurus is like dinosaur reptile. So it's a reptile that they found fossils of this reptile in South America and Africa. So that is an indication that those 2 continents were at one time connected. Because otherwise, why would you have the same species of animal, its fossils, in both places? Right? It'd be very, very, very highly improbable that this animal would evolve, or this species would evolve in 2 separate continents. So, evidence shows highly, highly probable that they all evolved, that species evolved one place, and then that place got divided up into the continents. All right, so that is biogeography, is locations of different species on Earth, where they are. And we can use that in fossilized evidence to indicate Pangea existed. Or wasn't alive, but there was Pangea, and continental drift and plate tectonics caused the continents to form as they are today. So, number 6. Stop and think. Stop, think. Number 6, I want you to tell me forms of evidence we have for Pangea. All right, so 2 forms of evidence for the presence of the supercontinent. It was like 250 million years ago. All right. Welcome back. Whoops. The Earth, I dropped the Earth. That's not good. You never want to drop the Earth. All right, so here we are, the Earth. We are back. Welcome back. And here we are. We are going to talk a little about what fossils are. All right? So fossils are remains of ancient life. Anything that shows life existed, and they don't have to, they can be millions and millions of years old. We know how the horse evolved over time. 45 million years ago, the horse was about the size of a small dog. And we look at the fossilized evidence over the years, and the horse evolved to become much taller. It actually lost its toes. 45 million years ago, the horse was like a dog, and it had toes, had like 4 toes in front and 5 in back or something. And over time, it lost its toes. So it didn't like lose a toe overnight. You know, I mean, it wasn't like it woke up in the morning and, oh my God, where's my toe? Like the next morning it lost another one. No, I mean, this was a gradual process. But we know that it happened because we look at the layers of rock and we see a transition. So at the very bottom, you're going to have the oldest fossils. And then as you go up, the layers of rock, you'll have the most recent. So the further down you dig, the older the fossils are. All right, so number 7, stop and think. 7. Number 7, I want you to tell me what biogeography is. Stop and think. Welcome back. Number 8, we're going on here. Number 8, I want you to tell me how we were able to determine the evolution of the horse through fossil record. So just describe a sentence how we knew the horse evolved using the fossilized evidence. I'll come back. Paleontology. Paleo, ancient, ology, study of, so it is a study of a history of life on Earth based on fossils. Okay, so paleontology is study of history of life. Great, stop and think. Stop and think. Why should we study fossils? I want you to just give me your own opinion. Why should we study fossils? Stop, think. Welcome back. Number 9. Number 9. Brutus doesn't know if he likes the Earth. Well, he likes the Earth, but he doesn't want you the Earth. Okay. Number 9, the question is, what is paleontology? Paleontology. Stop and think. Number 9. Welcome back. Last one, number 10. Number 10. I want you to explain why you think it is important to learn about history of life on Earth and history of the Earth in general. So again, this is kind of your own opinion, but I don't want to just look up, I don't want you to just Google it. I want you to think, why do I need to know this? Why? Right? Now, here is a picture of a fault line. So this could be like a San Andreas Fault separating 2 plates. So this could be, for example, this could be the North American plate, which is a plate where North America obviously is. And this is a Pacific plate. So this side's Pacific, and that is obviously where the Pacific Ocean is, a very large plate over here. So this is on the coast of California, about 800 miles long. And these plates are still moving. In fact, they move about 10 centimeters a year, the same rate your fingernails grow. All right, and in Los Altos, there's a fault line. There's a San Andreas trail where you can kind of walk along that fault line. So this is where they interact. Right here. I'm just kind of like zooming in on these plates. All right, and they slide past each other. So if they are sliding, this one's moving that way, let's say. Actually, this is the North American plate, so that one is going south. And the Pacific one is coming north. So as this one goes down, that one goes up, there's going to be some friction, a lot of friction here. And this causes earthquakes. This shaking, like, see, earthquake right there. That's what's happening. So it's a transform boundary. Transform boundary means two plates are sliding beside each other. So this is a picture of a zoomed in view of the San Andreas Fault.